All right, so today's first lesson on logarithms is as simple as can be. What we have to get you to do is understand that a logarithm, okay, and an exponential function, they're inverses of one another, okay? Logarithms and exponentials are inverses. So the thing is, to teach you logarithms, we're going to use exponentials, something you understand how to do, to get you to understand how to do logarithms. Look what it says up here. It says, when you have b, right, and y, oops, okay, all right. When you have b and y here, okay, and b is not equal to 1, okay, the logarithm of y with base b is written like this. So we read this as log base b of y, okay, and it equals x. Now that's true if and only if, and you study what that means in geometry, right? If and only if b to the x power is 1. Okay, so you see, look, this is exponential, right? This is logarithmic, right? We're able to go back and forth like this with these two equations, these two functions, okay, is what you're going to learn how to do. Okay, now look at this. The expression, okay, log b of y is read as log base b of y. We just talked about this. Okay, this definition tells you that the equation is log base b of y equals x, and this, b to the x power equals y, are equivalent. Once again, you can go back and forth with these two, which is how you're going to be taught how to do logarithms. Okay? The first is a logarithmic form, and the second is an exponential form. Okay, so here we go now. Here we go. Here comes the first thing. Rewrite the logarithmic equation in exponential form. Okay, so what is it that you do? The first thing you do is this. You drop the log. So strike out the log. And you make the switch. You make the switch. You trade places with the 8 and the 3. Okay, so then what would you write down? You write down 2 to the power of 3 equals 8. Is exactly right. 2 to the power of 3 equals 8 is what you write down. Now here's my question. Is that a true statement? Is 2 to the third power equals 8? Yes. Yes, of course. 2 times 2 times 2 is 8, right? So that's a good statement. We'll put a check mark on it. Makes sense. Okay, how do you do this? Okay, so here goes the next one now. Okay, same situation. Drop the log, right? Make the switch, right? So you're going to write what there? 4 to the 0 to the power of 0 equals 1, right? Now is that true? Does 4 to the 0 power equal 1? Of course, anything to the 0 is 1. You guys learned that. That's exactly true. Okay, what's the question? All right, okay, so let's go to C, right? Log 12 of 12 equals 1. So strike out the log. Make the switch, right? You write down 12 to the 1 power equals 12, right? Now, is that true? Yeah, of course. Anything to any power or any number to 1 power is itself, right? Okay. All right, let's go to D. Okay. Okay, so strike the log out, make the switch. Make the switch, okay. So you write down 1/4 to the -1 power equals 4, right? Okay, now. A negative exponent, what does it do to a fraction? It flips it, right? It does a reciprocal on it. So 1 over 4 becomes 4 over 1. And what does 4 over 1 equal? 4. Look at it. Sure enough, it makes sense. Look at it. Oops. Check. Okay. So we got that. All right, now, next part. Okay. Here comes something that you guys got to understand. Okay, there are a bunch of little properties you got to learn to do logarithms. So here's the first one you got to learn. Whenever you have a logarithm, right, and it's 1 that you have there, right? Any logarithm base to 1, right, it always equals 1. It always equals 0. That's something you can know, okay? So whenever you see a log of 1, you know it's going to equal 0 instantly. Nothing you can talk about. Now, on the other hand, look at this. Whenever the base and this number are exactly the same, right? But they're exactly the same. It's always going to equal the number 1, right? And you just saw that a second ago. You just saw that right here. Okay, 12 of 12, right? Log 12 of 12 is 1, right? Okay, what's log 7 of 7? 1. What's log 3 of 3? 1. What's log 15 of 15? What's log x of x? 1, right? Okay, so they're all 1, right? That's always true. And once again, it's showing you that right here, right? Because of this, right? B to the 1 is B, right? So that's why that's true. So those are things to memorize, to have in your head, because as soon as you see them, you say, oh, I know what that is. It's 1. Put 1 in its place. Okay, all right, now we're going to do these first ones in class, these first homework problems. Okay, so rewrite the equation in exponential form. Okay, so here we go. We're going to drop the log, make the switch. What would you write down? 4 squared equals 16. You got it. 4 squared is 16. Here's number 1. Okay, look at number 2. Drop the log, make the switch. What are you going to write down? 7 cubed equals 343. You got it. 7 cubed is 343. You got it. And let's go to number 3. Drop the log, make the switch. You're going to write down 6 to the negative 2 equals, okay, 6 to the negative 2 equals 136. Right now, okay, now look, here's 6. Here's a negative exponent. So whenever you have a negative exponent,
switch the top and bottom.
no, that's always you've been taught. When you have a negative exponent, you always put it under 1, right? Because we learned this earlier in the year, right? Okay, so here's a negative exponent, put it under 1, right? So you're going to have 1 over 6 to the positive 2. And now what's 6 squared? 36. So it's going to be 1 over 36. Makes sense? Okay, all these are old lessons now coming into play here. Okay, all right, now here's 4, right? So drop the log, make the switch. So 64 to the 0 is how much? 1. Okay, and anything to the 0 power is always 1, right? Okay, so everybody good with that? Okay, see, all right, now they're asking you to evaluate this. Tell me what it equals. Okay, so we got log base 4 of 64. Okay, so look how you're going to do this now. You're going to set this equal to x. Okay, now drop the log and make the switch, right? Drop the log, make the switch. So you're going to write down 4 to the x power equals 64. Now this is all what y'all do in your head, okay? What would x have to be? 3, right? 4 times 4 times 4 is 3. So it's x is 3, right? X cubed, or 4 cubed is 64. There you go. That's right. That's right. And you said that. See, that's what now there's going to be some unknowns that you start solving for. Yeah, so that's what you were asking about. Okay, so let's go to B. So log 5 of 0.2 equals x. Okay, so drop the log, make the switch. You're going to say what? 5 to the x equals 0.2, right? Okay, all right, now 0.2, that right there is a fraction. 0.2 is what? 1/5, right? 1 over 5. So what would x have to be? Negative 1. See, look how easy it is. Oh my gosh, it's got to be negative 1. Sure. 0.2 is a fraction. 1/5. So then 5 to 1 power would have to be 1/5. Negative 1, right? It's a negative exponent. You put it under 1, right? We just talked about that. That's what you learned earlier in the year. All these lessons are coming into play. Okay, let's go to C, right? Drop the log, make the switch. Okay? Like that, right? 1, 2, 5. There you go. Okay, good. Okay, all right, now look, this one's a fraction to the x power. But you want it to be a whole number, right? So what kind of number would x have to be? A negative number, right? So if it's 1 over 5 with a negative, it would be 5 over 1. Okay, so it's going to be negative what? Negative 3, right? 5 to the third is 125. Meaning negative 3, exactly. See, it's easy. Okay, now the last one's the one that's kind of close to what people of that. You got to think a second. Okay, so set d equal to x, right? Drop the log, make the switch. So you're going to write down what? 36 to the x power equals 6. Okay, so what power would make 36 into 6? 1 over. And that's right, very good. It's a fraction, it's 1/2. Do you remember that? Because what does 1/2 mean? 1/2 means square root, right? 1/2 means square root. That's something you learned earlier in the year. All right? Something you learned earlier in the year, okay? So x equals 1/2. All right, so now there are 2 kinds of logarithms that you guys are going to learn about, right? One is what is called the common logarithm. The common logarithm, okay? Which is a logarithm that has a base of 10, okay? Common logarithm, right? Has a base of 10, right? So look over here. Here's log base 10 of x, right? All right, that's a common logarithm. Now here comes the thing. There's another way to write this. You can also write it this way, log of x. So whenever you see log of x, you are supposed to understand its base is 10, right? Its base is 10. You know what? Do you guys realize you do stuff like that already? That you look at something, you instantly know that there's a number there, even though you don't see it? Okay, what would be an example of that? It's right. You got it. Exactly. When you see x, you know what is that? It means it's 1x. The 1 is understood. You see, you do the same thing. It's the same thing with this. If you see log of x, you understand that's a 10 right there. That's a 10. That's inside of it. That's its base. Making sense what's happening? Because you'll see this as we start doing problems. Okay, so you got that. Okay, now on the other hand, we have this thing called a natural logarithm. Okay, where the base is always going to be e. The base is e. Okay, now you guys know this because you did this on the calculator. Remember what buttons did you have to press to get to e? Second and what button? And ln. You see, the ln and the e are linked together, right? The ln and the e are linked together. So that's why the ln goes with the e. Okay, the natural log goes with the e, all right? Okay, so those are the two kinds of bases you got to understand about. Okay, now look, here's what you're learning how to do right now. Simple as can be. You're going to use a calculator to evaluate the logarithm, right? So all you're going to do is this. You're going to go to the calculator, hit the log button, press 8 in the calculator, and close the parenthesis and hit enter. Now you're going to see a bunch of numbers there, right? A long decimal. And we're going to round it to the second decimal place. So what's the answer? 0.9, right? Okay, 0.9, 0.90, right? 0.90, there's your answer. Everybody understand? Okay, now we're going to go to natural log and do this, right? So go hit the natural log button and put in 0.3 and close the parenthesis and press enter. And then round it to the second decimal place. What are you going to write down? What are you going to write down? Okay, negative 1.20. Everybody seen that? Negative 1.20 is exactly right. There you go. That's it. It couldn't be easier. See, it's simple to do this. These problems are easy right now. And there's lots of calculator stuff with logarithms. Okay, so look what it says. The wind speed s in miles per hour near the center of a tornado can be modeled by this equation. S equals 93 log d plus 65, where d is the distance in miles that the tornado travels. In 1925, a tornado traveled 225 miles through 3 states. Estimate the wind speed near a tornado center. It's as simple as it can be. You put the formula on the board. Here's the formula, right? Okay, now there's 220. What would you put the 220 in for? The d. Put the 220 in for d, the distance, right? Like that. Okay, and we'll push that into the calculator and tell me what it equals. Okay, 282.84. Is that what you're saying? 0.85, 282.85. Okay, now let me ask you something here. When there's been a tornado in the area and you're watching the weather on the television, do you hear the weatherman say, well, the tornado speed was 282.85? No, he always rounds it to what? What place? The ones place, right? He always rounds it to the ones place, right? Okay, so tell me now, what would you write down? 283, right? That's the answer. S is 283 miles per hour. There you go. Okay, so when we get the word problems, many times you round it to the ones place. It's just an everyday common sense thing. That's it. That's the lesson. You got it. You got it.